Howdy, folks. Last time we got a chance to talk about collisions, and we looked at the difference between elastic collisions and inelastic collisions. That is, collisions where objects bounce off of each other versus collisions where the objects stick to each other. So we're going to carry on with that same sort of idea by throwing bouncy balls or mud balls at things. But in this video, we're just going to throw a single ball. We're going to throw a ball at a wall, and it will either bounce, an elastic collision, or it will stick, an inelastic collision. And what we're going to look at is the change in the ball's momentum as it hits the wall. That change in momentum is called impulse. So let's look at our example. We're going to first throw a 1 kilogram bouncy ball against the wall. And we're going to throw it with the same velocity as we used in our previous example for the collisions, 5 meters per second. And we're going to answer the question of what is the impulse at the wall? What is the impulse of the object as it hits the wall? So we know if we throw it with an initial velocity of 5 meters per second, it's going to bounce. And it needs to conserve energy if it's going to bounce. So if it's conserving energy, its velocity coming out needs to have the same magnitude as coming in. So it bounces and it returns with a equal but opposite velocity of negative 5 meters per second. Now what we are focusing on is the impulse at the wall. So the impulse is defined as the change in momentum. That is final momentum minus initial momentum. And momentum is given by mass times velocity. So the impulse is then the mass times the final velocity, that would be its final momentum, minus mass times initial velocity, the initial momentum. And we can plug the values that we were given into this equation. The mass is 1 kilogram. Its final velocity is negative 5 meters per second. It has bounced and is now moving to the left with a negative velocity. Its initial mass is the same, but its initial velocity is positive 5 meters per second. Altogether, we have 1 times negative 5 minus 1 times 5 for a grand total of negative 10 and units of kilogram meters per second. So the total impulse at the wall is a negative 10 kilogram meter per second. Well, let's think about that quantity. Does the minus sign make sense? Well, yeah, it starts with a positive momentum. 5 times 1, 5 kilogram meters per second would be its initial momentum as it heads towards the wall. Impulse is how we change that momentum. So when we hit the wall, we first take all of that 5 kilogram meters per second of momentum away. We subtract 5 kilogram meters per second. We then need to give it momentum in that opposite direction. Give it how much? Negative 5 meters per second times 1 kilogram, or negative 5 kilogram meters per second. So in the process of bouncing off the wall, we first take away its positive 5 kilogram meters per second of momentum, and then give it another negative 5 kilogram meters per second of momentum, altogether for negative 10 kilogram meters per second of momentum. We take its momentum away and give it momentum in the opposite direction. And it all totals negative 10. That makes sense. Well, now, what happens if we use a mud ball? Well, we throw it with a velocity of 5 meters per second, and splat, it sticks against the wall. And if it's stuck to the wall, it has a final velocity of 0 meters per second. Well, let's compute the impulse. Impulse is defined as change in momentum, final momentum minus initial momentum. That is mv final minus mv initial. But in this case, our final velocity was 0. So we have 1 kilogram times 0 meters per second minus 1 kilogram times 5 meters per second. This is 0 minus 5 kilogram meters per second. for a total of -5 kilogram meters per second. Only half of the change in momentum as when we bounced the ball off the wall. And that makes sense because we did the accounting. This -10 kilogram meters per second, well, we first had to take away the momentum it started with and then give it more negative momentum. We only have to do 1/2 of that, or one of those two steps. In this case, whenever that mud ball hits the wall, all that happens is that it loses the momentum it started with. It started with 5 kilogram meters per second of momentum, and we took that 5 kilogram meters per second away. The impulse delivered was a -5 kilogram meter per second impulse. So it actually turns out that there is more momentum transfer when you bounce something than whenever it sticks. So if I'm going to, make a sail, for instance, this is an idea they use in astronomy. There's a concept of a solar sail. Just like you would have a sail on a sailboat catches the wind and pushes the boat along, a solar sail catches light rays. But if you're designing your solar sail to get the biggest change in momentum, you don't actually want to catch the light rays. You don't want them to stick to your solar sail. You want them to bounce. If you use a mirror as your solar sail, you actually get more of a change in momentum than if you just used some sort of dark material that would absorb the light. You get more of a momentum change when something bounces than when it sticks. And we have illustrated that here with our simple example of bouncy balls versus mud balls being thrown at a wall. So that's the basic idea of impulse. We'll see impulse in its other definition in an example here shortly. So stay tuned. It's one of my favorite examples. We're going to crack a ball out of the park. I'm going to hit a home run in our next example. So stay tuned. See you guys next time.